Hi there, everybody. I'm John McMillan, and welcome to PCB Tech Talk, the podcast where we'll be talking about pads, the EDA industry, and the questions you're asking. I'll be bringing in special guests, including subject matter experts, listeners, and EDA industry leaders. So be sure to subscribe to this podcast. We'd love to know what topics you'd like to discuss, and who knows, maybe you can be our next guest. Today I'm talking about the challenges associated with routing and auto-routing PCB designs, and what's being done, and what Mentor Graphics is doing to address these challenges. Traditionally, auto-routers don't have the best reputation for getting the job done. If you ask PCB designers, you'll often hear the results just typically aren't good enough, or they're comparable to what they themselves, the PCB designers, knows that they can accomplish with hand routing. Way back when I started with PCB design, it was back at Harris Corporation in the mid-'80s, you had to hand tape PCBs first. There was a CALMA system on site there, but that's not where you started out. One of the best things that hand routing taught me, and I'm sure a lot of the old timers can relate to this, is the necessity to really study and understand the design first. You're essentially visualizing many aspects of design as the finished product. So understanding and planning and visualizing the design really mattered then. And just imagine the work involved in having to rip up and retape and layer after layer and ruby lift and vias going through multiple layers of mylar. It was really a great task. You really wanted to avoid that if at all possible. So designers really had to think out and think of a mental picture of the routing strategy then as they were placing parts. And it's really not so different today. Your placement, you're looking at the rat's nest. You're looking at your component spacing and the orientation, and you're seeing how the rats are going from part to part to part, utilizing the schematic, using the placement, orientation of parts. So you're really creating and writing and actually drawing a mental picture of very close idea to what the actual end result needs to look like for the routes to get the board done. So in many cases, it gave up on autorouters to some extent, some people altogether. Even when autorouters completed 90% of the routes, manually fitting in the remaining nets, it could be a nightmare. Some of them, they accomplished the 90%, but they left no room for the 10% that it couldn't fit in. So it required extensive pushing and shoving and additional vias and a lot of ripping up. So any of the time you felt like you saved by using the autorouter, you felt like you were using back up by all the rework you had to do to get the remaining, traces in. Frankly, lots of designers have just thrown their hands up in the air. They determined and believed, and for good reason in many cases, that it's just easier, even quicker, to just route their designs by hand. And that's a problem. Tools that are designed to automate just haven't been getting the job done to the satisfaction of many designers. And the greater the complexity of the technology, the greater the problem in most cases. Like take a big A, little d design, where you can, analog stuff we typically do find that it's hand routed. But there's a lot of designs where you have small a, big D, where the digital stuff can just be turned loose in an auto router. But that isn't all the cases anymore. So when we break a PCB design into individual tasks, like library development, schematic, component placement, pre-route, etc., one of the biggest chunks of time spent is in design connectivity, turning all of those rats, thousands, even tens of thousands, in many cases, with all the rules and constraints they contain, into traces. It gets harder and harder, designs get more and more complex, and rules are nearly on every net these days. And PCBs are smaller and denser every year, and it's like putting 5 pounds of stuff into a 10-pound bag. It's getting hard. Routing is an art. You can actually tell some designers, when you've worked with them for many years, who actually did the design by looking at their technique. So the problem we set out to solve is, how can you get a tool to translate what designers have envisioned and essentially automate that? So that is the problem that new routing functionality called sketch routing addresses. The sketch router was created to accomplish that task in providing a fast and easy way to achieve manual routing quality in a fraction of the time. From evaluators, we got the feedback we received from SketchRouter was they were able to get hand-routed quality routing even after timing their own hand routing of the design as a benchmark first, and then using the SketchRouter to generate the routes. They reported they were able to achieve routing results that closely matched what they would have done with the hand routing. Some even reported that they were able to achieve those results up to 30 times faster than manual routing. That is pretty compelling when you take into account how much this can help shorten design cycles and get products to market sooner. So you're probably wondering how the sketch routing environment works. Well, the sketch routing environment, it provides a set of highly integrated automated routing features, including the sketch router itself, hug router, real trace routing, and Dynamove. These tools are combined for a routing experience that enables a user to control the high quality of routes that they desire. The SketchRouter designers, it's pretty simple steps. You draw a sketch path that kind of dictates your design intent, what you've envisioned. You can route individual traces or hundreds of single-ended or differential pairs. So with the SketchRouter, you can manage the location of the traces, the options for the route styles. You can choose via patterns. The route quality, you can make sure, you'll see that how closely it really actually matches the quality of the manual routing. And rarely needs cleanup. You'll be happy with what you get. And the performance, you'll note that it's also unbelievably fast. So designer, he'll draw a path, indicates the direction he wants the net lines to be routed. The SketchRouter can route individual dozens or even hundreds of net lines many times faster than manual routing. Also, if the nets to be sketch routed are not specifically marked or selected, the SketchRouter will select the nets that are the close approximation to each of the sketch route endpoints. Another great feature of sketch routing is the ability to route nets in either a packed or unpacked mode. In a packed mode, route spacing is optimized with minimum design rule values, as you typically see in serial nets. But in some cases, the unpacked mode is more desirable since it provides the most direct net connections and it avoids unnecessary overcrowding of traces. Sketch paths are simple to draw. The direction in which the path is drawn determines the start pins and end pins for the SketchRouter. And if necessary, the SketchRouter will even consider up to 10 different approaches to complete the routes for the selected nets. Each routing approach considers the routing results for each pin escape direction and then places the routes for the best routing approach. There's some other key aspects of these approaches the SketchRouter uses. They're called compression, centralizing, and glossing. Once the best approach is determined, the SketchRouter runs passes that compresses the nets towards the pins. This ensures that the route's pin escapes are optimized to accommodate further design routing. And then next is centralizing, where it centers the routes between the compressed pin escapes around the design drawn sketch path. So if no sketch path is drawn, the SketchRouter centralizes the routes between the compressed pin escapes. And then finally, there's glossing. During the glossing pass, the SketchRouter attempts to minimize trace segments to ensure that routes are as direct as possible. Autorouters don't know everything that designers know about getting from point A to point B. Sure, they're great at planning routes between two chosen points and calculating the distances and the shortest paths of travel, but in reality, we don't always get the results we were expecting. Knowing this, PCB designers tend to, dismiss autorouters, just as we sometimes dismiss travel routes suggested by our GPS, based on our experience, our familiarity with an environment or known obstacles and conditions. The same's kind of true with printed circuit board design routing. We trust our experience to give us guidance and make everything look right. But time is really of the essence these days. And so assisted routing with the SketchRouter enables PCB designers to route high-quality, rules-driven routes easily in very, very much faster times with all the quality and the look and feel of the hand-routed PCB. So we have a great opportunity for you to test drive this, and it's done from Mentor.com. You can go to sketch routing and actually run a virtual lab, which enables you to actually test drive sketch routing in real time and actually play with the results and without downloading anything. So I'd encourage you to go there and maybe take a look at that. Well, that's all for today. I hope you enjoyed this talk about sketch routing. I hope you're encouraged to learn more about it. If you have any questions, be sure and send me an email. And who knows, maybe you'll be the next guest on PCB Tech Talk. Thanks for listening.